Thank you very much for joining us. My name is Roman Gill from Jinko Solar, and I hope everybody can hear me. And we just want to make a short overview about our panels and technologies that we have. You know, Jinko is #1. Sustainability and quality are the things most important for Jinko. And for example, we start here, which is a standard Eagle in all black panel that's working, you see here, PID resistant, quality high standard, and low light performance is very good, weather resistance, and again, the quality is one of the most important advantages of Jinko. But let's go, this is a standard panel. Let's go to a panel extraordinary, this is here, if we are standing here. We can go to that one. This is an all black mono module that works with a standard optimizer that is in cell string level. That means here the MX is the second generation of it. That means that you have an optimizer sitting in every cell string. You know, every panel, doesn't matter if it's a 48, a 60 or a 72 cell module, has 3 cell strings. They are all connected in series. The consequence is that in a standard panel you have diodes as an emergency for any issue with a cell or shadow, anything like this. But this lowers, if it's activated, you are losing power, and the mismatch in the cell just has an influence on the current. So one bad cell influences the current of a module and in consequence of a complete string. And with an optimizer here, you always keep the current up. That means no matter what happens, if it's dirty, if it's shadow, if it's a mismatch in the cells of temperatures or so, you always keep up the current. At the end, the string, the complete module string, is not influenced or nearly not influenced by a cell mismatch. Whatever reason it is, you have no bypass diodes anymore. You have just the electronics with their 3 chips. They are working separately from each other with no contact to each other. They are, it's a plug-and-play system. They are very reliable. And at the end, you need a simple inverter with just one MPP tracking, because the MPP tracking is done on cell string level here by these chips. This is the point. The MPP tracking is made here. You always keep the current up, and at the end, for longevity, for a long life of the panels, you can rely on that the current will always be there that you need. So at the end of 25, 30 years, you will be sure that the current and the power output that is caused by this will be at the level as at the new model. Okay? More details is a little bit difficult because we have to speak about the IU curve, about the limited voltage and so on. It needs more time than we have right now. So I think we should go to the next panels over there. We need to go left side around here. Just follow me. Here you find some other very interesting panels. Just come around, please. This is a half cell technology. Does not matter what technology of cell you are using. You can use either a poly or a mono PERC, whatever it is. The process is that you take a first-class cell and split it into half by laser cutting technology. At the end, you have 2 half cell modules connected in parallel. This is done here in the middle. If you go to the back side, to the rear side of the panel, you see this is the part. The 2 halves are connected. You have small junction boxes, 1, 2, 3 diodes. You have very serious, very short cables. So you are reducing the losses. And the trick is here, because you have a half cell. The voltage is high as a full cell, but the current is 50%. And you know, the resistance is going in parallel or in square with the current. So if you have a loss in one of the cells, whatever it is, it influences only 50% of the cell, of the complete cells, and only 50% of a module in consequence. And the point is, at the end, you know the law of Ohm. R is U divided by E, and you know P is I times U. So the resist is square I times R, both together, if you calculate it. So the influence of the current, of the losses at the end or at the power output is in square. So the influence, if you are changing the current, is really, really high. At the end, this is not an MX optimized module, absolutely not. But the influence of shadow, the influence of temperature mismatch or anything like this is reduced. At the end, you get a higher power output because of a lower current, of the lower temperatures in the half cell, of a better temperature correcture factor that you get. And one other trick, we must go to the front side again. One other trick is here. You have more gaps with a white backsheet on between the cells. So the internal light reflection is better. At the end, the trick is to tune a module to get more light into a cell or to reduce the resistance, the Ohmsche resistance, or in this point the losses. Both is done here, the one by the 50% of the current, and the second, the reflection here. So light is coming into the cell, it's absorbed, so everything is good. If not, it goes here on the line, on the white backsheet, is reflected to the inside of the glass, and then, we hope so, thrown back to the surface of the cell and absorbed. So this is only a little bit, some tricks to get more power out of it. And at the end, you get a better performance, a better power output, and a longer lifetime about it because of the lower temperatures of a module, because of a lower current, it's the temperature reduced, and even the better absorption. Okay, this is in short words the benefits of these panels. At the end, for the mounting, it's more simple because the short cables, you do not have to do long cable loops or something in your rooftop if you construct it. You do not have losses about it. Okay, yeah, next panel. Sorry, we have not much time. Here we go to the multi-bus bar. The multi-bus bar is nearly the same. You have standard panel has 4 or 5 or 6 bus bars, but this number of bus bars available on the surface of a cell is limited. So at the end, if you do a fine mesh of bus bars, you reduce the losses of current, you reduce the resistance, and you reduce the shadow caused by the bus bars. Because every bus bar needs space on the surface of a cell, and so you reduce it by very, very, very thin lines, and the electrons have a good chance to get to the grid and to be transported and not for recombinations. And for the shortage of time, the last not least, and I'm open for discussions after this session here, this is a bifacial. Bifacial, that means both sides of the cell are active for light. You have a double glass. Double glass is for sustainability, for the long lifetime of a module, always good. It's frameless. Maybe in winter we will bring out a framed version. And you have the absorption of light from front and rear side. So you get more power output roundabout between, let me say, 8 and up to maximum 30%. This depends on cell technology and where you build and how you get the surface. The so-called albedo effect is the quantity of a reflection from a surface of a ground. I for myself have seen a module like this mounted on a residential rooftop, and he colored his tiles really in silver bronze. Was looking completely ugly, completely stupid, but at the end he tries to get out a little bit more power of it, and so at the end it works. But to be honest, underground with snow, underground of sand, something like this, concrete, there are existing lists of a reflection factor. And when you can calculate it, even with the angle and with the tilt and so on, you can calculate the better energy yield you can get out. Okay, this is in short words what I have to say. I think I'm in time. We have time for questions. That's good.
In percentage, what is the additional amount of energy you get from the half cell compared to the full cell solar
How much
system?
it is more?
Yeah, in percentage from the conventional.
Depends on where you use it, how you use it, shadow condition, temperature condition, things like this.
And what are the price difference between the transparent
100%.
half cell price cost per watt?
This one I can say, I can calculate between, let me say, 8 and 30%. On the bifacial, you can say between 8 and 30%. On the half cell, or multiple power or half cell? Half cell. This is power output, maybe it's around, I'm leaning out of a window, something about 1-2% more. But the price is nearly the same. And the point is you get around about 1 power class more out of a module. So I think it's better. You take the same cell, but for the temperature coefficient and for the inner reflection, 1 power class more. That means 320 has 325, and so at the end you get around about 5% more. Okay?
Yeah, firstly, I'm a very faithful Jinko customer in Egypt already, but for standard modules, I would like to ask, I mean, usually we had 3 busbar, 4 busbar, and then 5. Yeah. So is it like stopping at 5, then jumping to this multi, or there will also be like 6 busbar and so on in the future? I mean.
To be honest, around about 6 should be the end. And it makes not sense because you have the current transportation and the shadow. And if you go over 5 to 6 or more, the losses by shadow cost are more than the energy gain you get. So it's a minimax.
So this will be the next generation?
Yeah, I think we will bring it in parallel. I'm not sure what will happen in that point, but maybe we go to 6 and then it should be over, should be.
And for currently, how much the price difference and how many cents per watt is increased just for the...
Don't ask me about the price, I'm technical. Just just talk about the price with Ali, okay?
I want to make sure how much temperature can your module
when it works. What's the temperature level?
Yeah, because Middle East temperature goes sometimes more than 50 degrees.
No problem.
So no problem.
No problem. No. You have here under reality conditions, if you have a rooftop, and we are talking about a tilt of 30 degrees, oriented to the south, you get normally in a cell 70 degrees, and even up to 80, 85 or so, it's okay, absolutely okay.
And the performance, the efficiency will be the same.
No, it drops with the temperature coefficient. So normally under normal conditions here in Western Germany, you are losing from the testing conditions that in the data sheet. You find, for example, a 300 watt, and when you get around about 260, it drops. But it's simultaneously with the temperature is going up and down, but it's every module is doing like this. So you can calculate the power output with the temperature coefficient.
Do you have Solar Edge integrated modules, or you go the Maxim way?
First of all, it's called MX. Second is we had Solar Edge, and we had even Tigo in the junction box, but we kicked them out because they cause problem at the end. And you just can dance on one party. And I'm convinced from a technical point of view that the MX optimizer is the more simple and the better one. There are less electronic parts, there are less chances to miss something or to smash something. And if you take a look at the PCB of Solar Edge, it's big like this, a lot of electronic parts, a lot of capacities and inductivities. And at the end, I got claims. Normally it's a simple issue, but it's a failure on the roof, so the installer has to get up, to dismantle everything, to bring it down, to ask for a replacement, and sometimes it's only a jumper or things like this, but it does not work. So at the end, the MX is a plug-and-play system, and I hate this word, but fire and forget. You can build it and forget it, and it's simple and easy just running. So this is the technology. And the next point is that the Solar Edge is definitely, this is a technical issue, losing always 2% of power output. It's a must because of a double DC-DC converter.
Yeah, you get monitoring. That's the only.
Yeah, exactly. That's the point.
Yeah, thank you.